de frontière. Et li pa jamais ni barrière. Li ka pénétrer.
Math Morning, Mr. Dirk is back at it again. Today we'll be simplifying square roots.
So today we'll be talking about square roots. Quick review, radical square roots. These can be used almost interchangeably. Radical, this is actually just this sign right there. This symbol is a radical symbol. A square root, well, that's going to be the answer of a number inside the radical. So what's the square root of 36? That's what we say. And you can say to yourself, well, 6 times 6 is 36. So the square root of 36 is 6. And you might think, okay, well, what about negative 6? Negative 6 times negative 6, that's also 36. But no, right? This is the principal root, we call that. And if I put a negative sign in front, then my answer would be negative 6. But we're talking about principal roots, and that is 6. Another example, I might say 84. What's that? 84, not 84. How about 64? The square root of 64. Well, 8 times 8 is 64. So the square root of 64 equals 8. One more. How about 40? 40. Some of you might say, okay, 20, just because your brain is going crazy and you can't think of it. But there is no number, an exact number that multiplies by itself that equals 40, right? So that's what we're going to do today. We're going to be able to simplify this, try to figure it out. You might think, okay, well, I know the square root of 36, that's 6, right? The square root of 49, that's 7. So the square root of 40 must be between these two, probably closer to 6, but you really don't know. And we're going to use the product property of radicals to simplify this. All right, off the top of my head, I'm going to say that this is the square root of 4 times the square root of 10. The square root of 4 is 2 times the square root of 10. This process right here is what we're going to do today. So that's it. Let's go. All right, what we talked about in the last one was the product property. That is when you have two numbers, two products under a radical sign, you can just split them up and make two different square roots. So that's what we're going to start with. This right here is a number line. On the bottom you see 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Just a regular old number line. On the top, right, these are the square roots that simplify to these numbers on the bottom. Like the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 81 is 9. So this is a number line with perfect squares. This is extremely helpful in what we're going to do. Some people, right, if you don't want to write this whole number line, I'm going to let you write just these numbers on the top, right? You might do something like 0, 1, 4, 9, 16, 25, 36. This can be helpful in doing what we're doing as well. So here's what we're going to do. Step 1, write the perfect square number line or list of perfect squares. That is what we just did. I gave the number line to you and I wrote the list of perfect squares. So that's what we want to do when we're simplifying square roots. Step 2, start at the number given in the problem. Check each perfect square on the top of the number line until you find a factor of the given number. Write that number first under a radical. Alright, that's a lot of words, so let me do an example. If I had the square root of 72, alright? So I look up here at the square roots, 72. Well, that's going to be between 64 and 81, right? So it should be somewhere in there. It's going to be 8 point something. So that's where I start. Now I want to go back this way, right? Go down the number line until I find a factor of 72. So is 64, does that Can you divide that into 72? No, so I'll cross that off. 49, can that be divided into 72? No. What about 36? Well, yes, that can. So 36 times 2 equals 72. So what do I have to do? Write that number first under a radical. Alright, so I'm going to write the square root of 36. What happened next? What is happening next? Let's take a look. Step 3, write the other factor second under a radical. So we said that 36 times 2 is 72, so I write square root of 2 after that, right? 36 times 2 is 72. Now it says simplify the first factor written. Because it's a perfect square, it will always simplify to a whole number. If you choose one of these numbers on top, it will always simplify to the number below it, right? So the square root of 36 is 6. So my answer simplified is 6 square root 2. Boom, and just like that. That is your answer. So overall, we've got it says 4 steps. It's really kind of 2, but it's 4. So I'm going to show you another way to do it. No way is better than the other one, but you can kind of choose which way you want to do it. So we had square root 72, right? And that pretty much broke down to the square root of 36 times the square root of 2. The square root of 36 simplifies to 6, and we have square root 2. All right? If you use the number line, you're always going to get the biggest factor, right? And that's going to simplify. If you don't, and you say like, well, okay, the square root of 72, that can be the square root of 8 times the square root of 9, right? 8 times 9 is 72. And the square root of 9, that equals 3, right? So this is really, I could write 3 square root of 8. But the problem with this is not completely simplified, right? This 8 can be broken down again. You can say 3 times, instead of 8, that's 2 times 4, right? So square root of 2 times the square root of 4. And the square root of 4, that equals 2. So you have 3 times 2 times this square root of 2. And then 3 times 2 is 6, square root 2, all right? So you'll get the same answer, but it takes a couple more steps. It's kind of convoluted. So if you do this way with a number line, you'll always get the biggest factor, and you don't have to worry about, having a square root 8 and having to break it down again. This will be right the first try. But you could do either one. All right, here we go. Some more examples. So first thing, I'm going to write, instead of the number line, I'm going to draw the list. So we've got 0, 1, 4, 9. I need to go all the way up to 200. Let's see if I can do it. What comes after 9? 16, 25, 36, 49, 64, 81, 100. Ooh, what comes after 100? 121, 144, 169, 196, and then 225. All right, that's more than 200. That's good. So I've got my list. Little secret, you're never going to use 0 or 1. But why did I write them? Just to show you, right? This makes a complete list. But you're never going to use them. So what do? You go look over here, square root of 12. 12, that's between 9 and 16, right? So you start looking for numbers lower than 12. Is 9 a factor of 12? No, you can't divide 9 into 12. What about 4? Can 4 be divided into 12? Why, yes it can. All right, so I write square root of 4, and 4 times 3 is 12, so then I write square root of 3. And then the square root of 4, that simplifies to 2. So we have 2 square root 3. Boom, there's your answer. All right, 98, square root of 98. So that's between 81 and 100. So is 81 a factor of 98? Nope. 64? Nope. 49? Yes. Yes, it is. So we write square root of 49. And 49 times what equals 98? Well, that's going to be the square root of 2, right? 2 times 49 is 98. And the square root of 49, what does that equal? Well, that's going to equal 7. So 7 square root 2. Ba-bam. And if you don't know, like how to find the factors of 98, I don't know which one's right. Here's what you can do. Go on your calculator, and you just take 98, and you divide by all these. So 98 divided by 81. There we go. So 98 divided by 81. Oh, not plus. Alright, that's a decimal. No good. 98 divided by 64. That's the next one. 98 divided by 64. Nope, decimal. Not good. Alright, 98 divided by 49. 98 divided by 49. And it's 2, right? You have a whole number. That's when you know you have a factor. Alright, last one. Square root of 200. Well, that's all the way down here. That's between 196 and 225. So let's do that with the calculator. See which one works. 200 divided by 196. Nope. 200 divided by 169. Nope. Okay. Ooh, look at that guy. He's back. What's next? 200 divided by 144. What? I mean, that won't. 200. That can't be divided by that. Let me just double check. 200 divided by 144. Nope. 121. 200 divided by 121. Nope. All right. 100. Well, I think that one's going to work. I have a hunch it will work. 200 divided by a 100 is 2. Perfect. So when I write this, I write the square root of 100 times the square root of 2, and the square root of 100 is 10. 10 square root 2. So if you do it this way, you don't have to worry about doing like a big tree and doing multiple things. You just get it right on the first try. Awesome. All right, so here we go. This is a little different. We've got some numbers in front of the square roots. Let's see how we do it. First, where's my number line? First, where's my number line? There we go. Let me fix that. So the number line's there. When you have a number in front of the radical, we just treat it like a multiply, right? So this is going to be -4, and now we do what we did before. So 300, right? I could extend this, but I know the numbers above 225, they won't be divisible into 300. It won't work. So if I go down, I could use my calculator, but I know 100, right? That's going to be divided into 300. 100 times 3 equals 300. So this, you can do square root of 100 times the square root of 3, and then the square root of 100, right? Ooh, I said a common mistake. Let me show you. Some people might do -4 times the square root of 10. Well, the square root of 100 is not the square root of 10. It's just 10. If you go from a radical and you find the square root, you get rid of that square root sign. So it's -4 times 10 times square root 3, and then you just multiply -4 times 10, which is -40 square root 3. Ba-bam, done. Over here we've got 2 square root 18. So 18, where's that fall on this number line? Well, boom, 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 up between 16 and 25, right? So can 16 be divided into 18? No. How about 9? Yes, it can. 9 times 2 is 18. So this becomes 2 times the square root of 9 times the square root of 2. All right, 9 times 2 is 18. This simplifies to 2 times this. Nope, I did it again. 2 times what's the square root of 9 is just 3. And this one stays in the radical, like that. And then 2 times 3 is 6. 6 square root 2 is the answer. All right, let's keep going. We've got 10, square root of 108. So 108. All right, that's between 100 and 121. Can 100 go in there? No. 81? No. 64? No. 49? No. 36. Well, I think 36 times 3, right? That's 18, 9, 10. Boom, okay. So that works. 36. So this can be 10 times the square root of 36 times the square root of 3. Square root of 36, that is 6. So we have 10 times 6 times square root of 3, and that becomes 60 square root of 3. All right, moving. We're moving. This is great. All right, now we're looking square root 33. So where's that? Well, that's between 25 and 36. Can 25 go into 33? Nope. 16? Nope. 9? Nope. 4? Nope. 1? Yeah, 1 can. But I told you before, right? We don't even use these ones. They won't really help you simplify anything. So this, it just stays square root 33. Nothing else can go in there. You might be thinking, well, hey, what about square root 3 times the square root of 11? I could break it down. But these are not perfect squares. We only care about these numbers right there. So those two numbers, they're not perfect squares, so it doesn't really help you simplify. All right? Okay, so now I want you to try 8 and 9. Try them on your own. Give it a shot. Pause and try.
Gentlemen, tell me why are we wasting time on all your wasted crown?
All right, here we go. So you could have drew this number line a lot longer. Well, the biggest square root the perfect square that goes in the 1000 is 100. It's negative, so you keep the negative on the outside. Square root of 100, all right, is going to be 10. All right, we kept the negative on the outside, so that's why you have negative 10. Square root is 10. And this 10 right here, 100 times 10, 1000. This one, negative square root 26. All right, so 26, that's between 25 and 36, right? Can any of these go into 26? Nope, 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 nope. So it just stays just like that. All right, so that's it. There's only 2 sections in this chapter. You're gonna kill it. So good luck with this, the packet. Good luck on the mastery check. Dirkus out. I'm gonna leave you with a video. This was when I was in college, the first viral video, I feel like. So check it out. You might like it.
And one of the things that's done is right here, these buckets are filled with grapes. What kind of grapes?
These are filled with Chambourcin grapes, and the winner this Saturday who stomps the most juice will actually win an overnight stay here at Chateau Lalanne.
You ready?
You ready to try it?
Yeah, sure.
Let's go.
Not disgusting.
Let's
All right,
go.
you ready? Give us a 30-second time. Here we go. So what's the deal here? There's a contest to stomp, and how are you measuring who does the best stomping?
And whoever stomps the most juice wins an overnight stay, but it's not the only thing you can do.
The measuring cups are down below, right?
Measuring cups are down below.
All right. And if you win, you get to stay at Chateau Lalanne. And what else do you have going on here?
Well, if group stomping's not your thing, you can come and spend the day listening to live music, eating international foods, having wine tours and tastings, vineyard tours, seminars, arts and crafts. It's a lot of fun, a whole day. Stop. Oh, stop.
I can't breathe. Stop.
No.
Oh
Boy,
dear.
I think she's actually hurt.
No, I
there.
think she is.
Yeah, she's hurt. She took a hard fall off there. Boy,
Okay.
gosh, I hope she's okay.
Okay.
Mm.
We're going to make sure she
We'll
is.
try and
Jess
check
is
on
there.
her and get back
All
to you
right.
as soon as we can.
We'll be back right after this.